branches of chemistry that is obviously very, very important. And then from there, we'll look at the different parts of chemistry that you would need for your exams, and then we'll break it down step by steps to see how far we can go into all of that. Now, before we go into rudimentaries, let's start with what chemistry is and the big parts of chemistry that we have. Now, basically, we can say that for chemistry, we are simply studying matter. Now, that is the blankest way in which you can talk about chemistry. Now, what exactly is matter? When we talk about matter, we are talking about anything that has mass and occupies space. Now, of course, this exactly has a lot of hidden meanings. For instance, we are specifically talking about mass and not weight. Now, one of the major conversations that has always been appearing in secondary school is what is the biggest difference between mass and weight? The biggest difference between both of them is gravity, G. The existence of gravity brings the biggest difference between mass and weight. Of course, for the physics guys, they would talk to you about scalar quantities and vector quantities, but let's talk about it in the real sense of the word. For mass and weight, the biggest difference between them is gravity. Why? Because mass simply talks about the quantity assigned to that object, while weight talks about the quantity assigned to that object with respect to gravity. And that's why we'll say that W is equal to mg, which is a formula that is very, very common in physics class, right? Where m is the mass and this g is your gravitational constant. Sometimes it's 10, sometimes it's 9.8, as the case might be. So this is why it is very, very important to, whenever we define matter, we define as anything that has mass and occupies space. Now, for this study of matter, what are the different realms or what are the different ways in which we can effectively study chemistry, study matter? We can either decide to study it in its atomic form, and that's the branch we call atomic chemistry, or we study it in its physical form. Physical chemistry. So let's use these two. When we say atomic chemistry, we are talking about concerning ourselves with the insides of that object, right? Not its outward appearance this time around, but the insides of that object. Now, when we talk about insides of the object, we are talking about the atoms, the molecules, the ions that make up that object. We will define what those things mean, as well as the constituents of that object itself. How exactly are they bonded? What kind of bonds do we have between them? However, when we talk about physical chemistry, we are talking about the outward outlook of that particular object. What exactly happens if I throw that object to the wall? What happens if I hit that object? What is the shape of the object? How exactly does the object appear when it is shown or pierced through with light? How does it look like in the sun? How does it look like in the moon? All of those physical appearances blankly can be termed physical chemistry. So this can be said to be the biggest classification of chemistry we can have. Now, in terms of branches, for some of you that might study biochemistry or chemistry in the university of medicine and surgery or any kind of chemical inclined course, it's very, very important to know that in the university, chemistry is broken down into three realms, basically. Three realms. Now, for chemistry, we break it down into three categories. We talk about pure chemistry, talk talk about applied chemistry, and then we talk about physical chemistry. So sometimes people feel like, okay, when we see anytime we talk about pure chemistry, we are talking about the theories in chemistry, the bookworms, right? Your Dalton's atomic theory, your Boyle's law, your Charles law, all of those theories put together, pure chemistry. When we talk about applied chemistry, we are talking about the usages of all of these theories towards creating new things. How exactly are they applied? Ionization energy, bond order, all of those applications, right? Applied chemistry. And then physical chemistry, just as we have explained here, the practical utilization of chemistry. That is chemistry in industries, chemistry in machines, chemistry in engineering fields, all of that put together. In fact, you could talk about chemical engineering, which is a branch of the Faculty of Engineering, as a branch of engineering that utilizes more of physical chemistry compared to pure chemistry. So you find the pure chemists usually in the lab trying to figure out new elements and new compounds and all of that, talking about their components, their constituents. Or you find the physical chemistry trying to apply the usages of all of those things. I give you a good example. Lithium is an element on the periodic table. It's an element that has been discovered. It's an element of atomic number 3 and so on and so forth. That's for the pure chemist to do. However, with applied and physical chemistry, lithium has been used or converted into usages in batteries. So for some of you that are very, very sharp or have picked notice to it, you'd find out that in your batteries, usually the batteries in your phone batteries, when we were still using phones that had removable batteries, or the batteries in your laptops, they are always tagged as lithium ion batteries. Most of the time, they are lithium ion batteries. You also have batteries with other elements as well, but lithium ion batteries are very, very common, right? And it's not just in phones, you also have them in batteries for your watches, that's your wall clock, your torchlight, and all of that. So, those are applications of chemistry and chemical properties and chemical elements and all of that. So this is pretty much what chemistry looks like as a branch of study or as a field of study if you would wish to go into it. Now, let's start talking about chemistry as a subject, which is, of course, our biggest focus in class today. For chemistry as a subject, we are simply talking about what are the major parts of chemistry, what are the important things that you need to know about chemistry, where would those important things start from, how would I start piecing it together. We'll look at all of that in detail together. So we'll start from the very basics. We'll take those terms one after the other, and then we'll define them as well as get clarity on any parts that we have issues with. So let's begin. Just to see if I have more comments. Okay. So let's start from the very basics of chemistry. The very first thing is, how exactly do we know the objects? We have said chemistry is the study of matter. Matter occupies mass, has mass and occupies space. How exactly do those objects look like? What are the kinds of objects that we would have? Now, for this case, the most fundamental object that we have in chemistry is the element. when we talk about the elements in chemistry, we are talking about that fundamental term that extends to every other thing that we talk about. Now, the element is very, very important because from the elements we can combine them to form compounds, we can combine them to get mixtures. We will talk about what all of those things mean. From these elements, in fact, we can also study each element and talk about the insides of these elements. What are the constituents of these elements? All of this we will be looking at over the course of our class. But let's start with the element first and foremost. Now, the element represents an object or an item with unique characteristics in chemistry. Now, there are a list of these elements that has been discovered over the years, whether in labs or in nature. Now, when I say labs or in nature, this is because some of these elements are found in nature, meaning that they are already pre-existing and then we discover them. Good examples is the elements oxygen, nitrogen. These are elements that are found in air. And then we discovered that, okay, these are the constituents of air and we could call them oxygen, we could call them nitrogen. And we named them and they became elements. There are also some other elements that are discovered or created in the labs as a result of mixing different experimental processes together in order to form them. Elements that are created in the labs would usually be found elements with atomic numbers well beyond 100 most of the time, because at that point scientific advancements have begun to grow and we have begun to have much more researches towards forming these elements. Now, let's start first and foremost with creating a good understanding of the first bit of elements that we have. Now, the first 20 elements that we have and how, when I say first 20, how exactly are they arranged? They are arranged in what we call the periodic table. Later on, we will still discuss the periodic table as well as a topic. But first and foremost, let us consider the first 20 elements in the periodic table. We'll talk about some characteristics of them, and then from there, we'll continue to extend our knowledge. Now, we'll list them out. Hydrogen first, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, what's the thing I was typing? fluorine, argon, potassium, calcium. So here we have our first 20 elements in the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. It is expected that at least you should have these first 20 elements close to you and understand some basic characteristics of these elements. Now, what are those basic characteristic elements that we are talking about? The very first thing is the arrangement of those elements and the constituents of those elements. Now, those are very, very important things. So we would keep this list of elements here. This is what we are going to be using for the majority of our class. And then we will pick each concept and use the first 20 elements to show more light into those concepts. So let's begin. The very first concept we'll be talking about is the concept of the atom. Now, John Dalton talked about the fact that the atom is the smallest indivisible part of an element. What that means is that for an element, it is consisting of atoms, which means if you take an element, if you take hydrogen, for instance, within hydrogen, you would find an atom in it. And this atom is the smallest indivisible part of that element. Later on, it was proven to show that it is not indeed the most indivisible part of the element. In fact, the atom itself still contains some other parts inside it. Now, what are those parts? So instead of saying atom is the smallest indivisible part, we'll say this is the parts of the element that contains the proton, the neutron, and the electron. So, atom that Dalton believed was the smallest indivisible was in fact divisible, and it contained the proton, the neutron, and the electron. That was the very first thing. Now, how exactly is this proton, neutron, and electron positioned within the atom? It is positioned in such a way that it splits the atom into two categories: the circumference and the nucleus of the atom. So, if this is a diagram of our atom, for instance, we have the circumference. Now, with good knowledge of mathematics, this looks like a circle. The circumference is simply the line around the circle. So if this is the circumference, on the circumference is where you would find the electron. Whereas the proton and the neutron are found inside the atom. And where exactly do we find them inside the atom? We call where we find them, we call it the nucleus of the atom. So that's why sometimes when you see questions that says, what are the constituents of the nucleus of the atom? It is simply the proton and the neutron. So the proton and neutron, which are two of the three parts of the atom, are found or clustered inside the nucleus of the atom, whereby the electron, which revolves around the nucleus of the atom, is is found on the outer part or on the circumference of the atom. So the next thing that also draws very, very big importance to this is the mass of the proton, neutron, and the electron. The proton is equal in mass to the neutron. The proton is equal in mass to the neutron. They have exactly the same mass. And when we measure the mass of these particles, we measure them in terms of the carbon atom. We will talk about that later on in detail. But usually, carbon atom, which is, of course, element 6, forms a very good base for measurement of mass in chemistry. We will talk about why later on. And once you start picking the characteristics of the element, you begin to see why the carbon element is in a very, very good position. But let's keep that now. So proton is equal in mass to the neutron. We usually say it is exactly 1 unit of the carbon atom, whereby the electron is 1/1840 units of the mass of the carbon atom. So, while proton is equal in mass to neutron, of course, equal to the mass of the carbon atom, the electron is 1/1840 units of that mass, which makes it extremely lighter than the proton and neutron. Hence the reason why it cannot stay in the nucleus of the atom. Because it's so light, it can only float around the orbit, making sure that it just stays attached to the atom, but it's not inside it. So it is because of the lightness in its mass. So take note of that. So electron is 1/1840 the mass of, either you say mass of the proton or neutron, or you say mass of the carbon atom. Anyone is fine. Now, I haven't talked about the mass. The next thing to also talk about is the charge on these constituents of the atom. The proton is positively charged. The neutron is neutral, just as the name implies. Neutron is neutral. And then the electron is negatively charged. So this is very, very important. Proton is positively charged, the neutron is neutral, and then the electron is negatively charged. So this gives you a good mix of not just the mass of the constituents of the atom, but also the charges for each constituent of the atom. Now, that is very, very important. We would also still have some concept on the constituent of atom that we will not talk about now, but I'll mention it. The next, the concept that I'm referring to is the concept of the mass number and atomic number of an element. We'll get to it in a bit, but I don't want to jump the gun because we have something very, very important. Remember, I said we are going to be filling this by using some of the concepts here. Now, to mention briefly, the mass number is going to be the sum of two of these constituents. We will take the sum of the proton number and the neutron number to get the mass number, whereby for the atomic